We're going to go ahead and continue our discussion about exponential functions, and in this lesson we're going to take a look at how to translate the graphs of an exponential function. So go ahead and pause the video and take your notes down on all the translations and transformations we can do. Alright, so the very first thing we're going to do is we are going to graph our parent function, and in this case I'm going to do an exponential with a base of 2. And again, my exponential function has my input or my x value in the exponent. So let's go ahead and graph it. From the last lesson, we said that we graphed 3 basic points at -1, at 0, and at 1. So let's go ahead and plug in a -1 into this function. We get a half. If we plug in 0, anything raised to the 0th power is 1. When we plug in a 1, we get 2. And you can see how this function is going to curve up. And we said that for all exponential functions that are not translated or transformed, they have an asymptote, a horizontal asymptote here right on the x-axis of y equals 0. So I'm going to pencil that in, and remember an asymptote is a line that as your x value increases to infinity or maybe potentially decreases to negative infinity, our graph approaches that line. So let's go ahead and see what happens when we subtract a number from our exponent. So let's start off with plugging in our 0, 1, and -1 and see what happens, and we may need to plug in a couple more numbers. So at 0, we get 2 to the negative first power, which means the reciprocal of 2, so we're going to get a half. At 1, 1 minus 1 is 0, 2 to the 0th power is 1. If we plug in a 2 here, 2 minus 1 is 1, 2 to the first power is 2. And let's see, at -1, at -1 minus 1, that's -2. So we take the reciprocal of 2, a half, and square it, and we get a fourth. And it looks like our graph is going to look very much like our blue graph, except it's being moved over by 1. And you can see this horizontal translation in between each of these points looks like it's being moved by 1. So that is a horizontal translation, subtracting a number from our x value in our exponent. All right, let's see what a plus does. We should be able to anticipate this. We know that if we subtracted a 1, it moved our graph to the right. Adding a 1 should move it to the left. So let's go ahead and plug in a 0. And we get 0 plus 1 is 1, 2 to the first power is 2. If we plug in a -1, -1 plus 1 is 0. Anything raised to the 0 power is 1. If we plug in a -2, we get -2 plus 1 is -1. That is the reciprocal of 2, so we're down here at a half. And it looks like it is following the same rule. It is just a shift over by 1. And you can see all of these points are shifted by 1 from our original graph. So those are horizontal shifts. So let's now talk about vertical shifts. If we're adding or subtracting a number from our graph, it is not just moving our graph up and down, this part of our graph, it is going to also move our horizontal asymptote up and down. So let's take a look at what happens when we move our graph up by 1. I am going to anticipate that not only our graph goes up by 1, but our horizontal asymptote moves up to y equals 1 as well. So I'm going to go ahead and label that. If I put in a 0, that's 2 to the 0th power is 1 plus 1 is 2. If I put in a first power, 2 to the first power is 2 plus 1 is 3. If I put in a -1, we take the reciprocal, we get a half, plus 1 is 1 1/2. This number will still be a positive fraction no matter how far to the left on my number line I go. So therefore, this graph will still be greater than 1. So it reaches or gets very close to touching our horizontal asymptote, but never quite does. What does it look like when we move it down? Well, I'm going to anticipate here as well that since we're moving our entire graph down by 1, it will come close to my horizontal asymptote of y equals -1. If I plug in 0, 2 to the 0th power is 1 minus 1 is 0. If I plug in a positive 1, I get 2 minus 1 is 1. If I plug in a negative 1, we take the reciprocal again. We get a half minus 1 is negative a half. Let's go ahead and plug in -2 just to make sure. -2 is the reciprocal of 2 1/2 squared. So that's a quarter minus 1 is -3/4. And again, it's going to get close to my horizontal asymptote and never touch it in the negative direction. And now let's go ahead and take a look at putting a negative in front. And remember, PEMDAS tells us to raise our exponent first. Our number is going to be raised to the exponent. We do exponents, then we do the multiply by the -1. So let's go ahead and put in a 0 here. 2 to the 0th power is 1, multiplied by -1 is -1. So we're down here. If we put in a positive 1, 2 to the first power is 2, multiplied by our -1, we get -2. If we put in a 2, 2 to the second power is 4, multiplied by -1 is -4, and we are down here on our chart. If we put in a -1, that tells me to take the reciprocal of 2, which is a half. A half times a -1 is -1/2. And then if I put in a -2, I get the reciprocal of 2 is a half squared is a quarter. Now I'm going to multiply by my -1, and I'm up down here at -1/4. And I am going to approach this y equals 0 line very quickly, but you can see that a number in front, a negative in front of my base number, or that should be a 0, a negative in front of my base number here. Here's my base. If I have a negative in front, it's going to reflect my graph across the x-axis. And I've got one more example that we're going to do. We're going to do a stretch. We're going to take our original parent function 2 to the x, and we're going to multiply it by 3, and let's see what happens there. Instead of it looking like this nice blue graph over here, we should see it stretched by a factor of 3. Let's go ahead and stick 0 in. 2 to the 0th power is 1 times 3 is 3. In our original function, if we stuck 0 and we got a 1, now we're getting a 3. If we stick 1 in, 2 to the first power is 2 times 3 is 6. So we are all the way up here at 6. And in our original function, we were only at 2. 2 times 3 is 6, and that's where we get that one. Let's see if we stick in -1. We get the reciprocal of 2 is 1/2 times 3 is 3 1/2. So we are at 1 1/2 right here. Let's go ahead and stick in -2. 1/2 squared is 1/4 times 3 is 3/4. And if we stick in -3, we get 1/2 cubed is 1/8 times 3 is less than a half. And now we're starting to approach our our x-axis again. And our graph is going to look like this. Has a steeper curve, and it's stretched by 3.